Thanks. I'm Pete Munoz. I'm an ecological engineer with Biohabitats, based here in Portland, Oregon, but get to do work around the planet, which is super fun. Maybe just 15 seconds on Biohabitats. We're a multidisciplinary firm. About half of our technical staff are scientists, so ecologists, geologists, geomorphologists, all sorts of ologists. The other half of our technical staff are engineers and landscape architects. So we are kind of a traditional water resource A&E firm. One thing that is unique, that a few years ago we became a perpetual trust. So if you're familiar with the Patagonia story, we are a perpetual trust with a mission to restore the earth and inspire ecological stewardship. So we are still a for-profit firm. We just have a single shareholder, and that is Mother Nature. So all of our profits go into restoring the earth and inspiring ecological stewardship. So super fortunate to be doing this work. I have 15 minutes to talk about water and ecology. So I'm going to go quick, maybe fly through a few slides. But I was asked to talk about specific tools and approaches. So I'm not going to talk about the how or why, specifically what you can do or what people are doing in this space. So we all have been in the doing, having less of a footprint. We are more in the mindset that we need to increase our handprint. And what I mean by that in the water space is really kind of connecting our water resources to the, four different, through communities, four different things. And how we tend to think about this is liabilities. I'm a wastewater engineer. So our water that we use are liabilities that we have to manage, and we're trying to lessen impact. And that's not the right way to think about it from our perspective. We really want to think about resources that are providing services in order to enhance what we want in our communities, in our buildings, and so forth. And so that's kind of one thing we like to kind of outline within our work. I'm going to skip through a little bit of this, but essentially we talk about water being used once. It's used for a bunch of stuff, but in reality there's a ton of resources that we tend to forget. And so what we need to think about is how are we quantifying these resources and reusing them responsibly within our buildings or around our community. And there's a variety of ways to do that. One of the tools we often use is different graphical representation. Often this is very useful for non-technical audiences. So we highly recommend different tools like this. There's a diversity of approaches. When we're talking about specific interventions, we're not just talking about new infrastructure, we're talking about education and behavioral changes and systemic issues within our buildings or management systems. And so there's a variety of things. We could have a whole session just on this. But what this points to is that we need to figure out where to prioritize our engagement. And so a couple tools that we've been using more in the water space, and as a licensed engineer, I'm required by law to explain some sort of graph in a presentation. So here's that. On the left side, if you can see, this is just hours of the day and water use. And so midnight on the left side to midnight on the right side. And these are every dot is a 15-minute water use increment. And so what it really does is it tells us in a particular building, this was done for, let's just say, a nameless social media company. And so we're able to prioritize when specifically in a day are we using the most water, and where can we target education programs for specific staff? How do we target efficiency in the processes that are happening at that time? Like really specific data. On the left side is just kind of another graph that's showing overall use. So we know in this particular cluster of buildings that the kitchens are way more use than our flushing demand or other non-potable demands. And so it really focused our effort. Like, if we want meaningful change in water, we need to focus on kitchens. So deep data. And it really helps us to, again, graphically start to paint the picture of how we're reusing water and looping it through for multiple purposes, some of which I'm not going to get into because I'd rather spend more time talking about ecology, which we will do in a second. One last slide on water. Big data is really interesting. I showed a couple examples of kind of building specific data. This is Cape Town, South Africa. We were asked to go there, if you remember, a few years ago. They were headed towards day zero, where a city of 2 million people ran out of water. And so one of the things they did is we targeted specific areas where this is metered utility data. So the darker the red, the more water use. So they really were like, okay, we need to do more education, more, if we're going to do efficiency projects, we're going to look at fixture replacement in these targeted neighborhoods. So really powerful tool. And this kind of data is free and exists in almost all of our jurisdictions. We're not going to talk about this because a lot of there's all sorts of water stewardship programs. Many of you are part of them. We can move on. Okay, so we're going to, I do want to highlight one more thing, sorry. Last slide on water. U.S. Water Alliance has this One Water framework, which is super useful. And one thing in our work that we like to highlight are kind of water scale or watershed scale thinking, right? Not just very specific building focus. And that every dollar invested or every square foot used needs to have multiple benefits. And so we'll see that in a lot of our work, and we'll kind of see that actually when we talk about some ecological solutions. Okay, nature positive. How many people have heard nature positive as even a thing, right? This has kind of exploded in the last decade, really in the last 5 years, because of a global movement that's understanding that the planet's important, ecology is important. When a lot of people kind of use this biodiversity term as a general catch-all, but they might not understand, like, one, what it is, or two, how to measure it. And so I'm going to go over a few things specifically about biodiversity when I'm talking about this kind of nature positive space. The one thing to note is that the biggest threat to biodiversity is habitat loss and fragmentation. So that's very clear within the science and kind of where we're headed. And when we talk about biodiversity, we're not just talking about species diversity, we're talking about genetic diversity, we're talking about behavioral diversity. There's a whole slew. This could be a whole nother our presentation just on specific diversity. We've come up with kind of this, so we have a lot of corporate clients that come to us and say, we want to improve biodiversity, but we don't know either where to begin, or we have some specific things that we like. What tool do we use? How do we measure that? So we've kind of created this little framework and kind of explain it a little bit. As you go up, you have more complexity and more expertise needed. And as you go left to right, you have more ecological potential or more potential to enhance kind of nature positive solutions. And so I'm going to talk about each one of these super quick. I don't know why these dots are there. We're going to jump in. We're going to start on the bottom. I know where the dots are there. We're going to start at the bottom left, and we're going to work our way up the ladder. So the simplest, diversity by proxy. How many people use a diversity by proxy tool? How many people might but not know that they're using one? All right. So there's a handful of tools that are basically looking at area-based metrics. So the simplest example is an acre of lawn is less diverse than an acre of meadow. Right? So you kind of get that idea. And there's a bunch of different tools that you can put square foot numbers into a whole database, have a bunch of land performance topology that you go through, and fairly quickly you can rank where you're at. And if you change a type, if you build a building on a parking lot and put a green roof on it, maybe it's going to have a higher diversity score. Or if you convert lawn to a wildflower meadow, maybe you're going to have a better score. So there's a whole bunch of things like this that make kind of entry really easy. You do need someone to kind of assess and evaluate and fill things in there and give you kind of a plan to go forward, but this is a tool that's used quite a bit. And there's probably 5 bigger platforms that are used, and we just evaluated them for a few clients because they have some nuance. The second one is kind of these ecosystem services. How many people have heard this or have some of this baked into their ESG? So this is used a lot in the conceptual and schematic design phase. So it's looking at a lot of our open spaces, it's looking at green infrastructure, it's how do we take specific things that we care about in the ecosystem service space, and how do we embed those within our communities or within our buildings. Obviously, there's a ton that get baked into this, but this is kind of a language that a lot of corporations and a lot of communities and a lot of stakeholders can digest, and so this can be a useful framework. Kind of, what happened? I don't know. Moving up, kind of middle of the road, so this is the Society of Ecological Engineers reference system approach. So if you're familiar with the Living Building Challenge, and you look at the ecology pedal, this is what that framework is based on. And so what it does is look at a reference site, which is a site near your community or your building, and says, here is a native ecosystem that's well functioning. Let's look at my community or building, and let's compare how close they are. And then you can say, well, I'm pretty close in some of these metrics, but there's a few that I'm not close in. What can I do to move the needle, to shift closer to a reference ecosystem? There is a whole, this is from the Society of Ecological Restoration, so there's a whole scientific protocol where you can go deep, deep, deep into all of these. But it does offer kind of a simple framework and a comprehensive framework to look at a more specific ecological principles than just some of the spatial stuff we were looking by the diversity with proxy. So this can be a super powerful tool. How many people have used this? Just curious. None. Anyone done any Living Building Challenge stuff? Eric, put your hand down. Okay. 1, 2, 3. We're up to 4. Functional approach. So this is a really interesting one because it's typically not very green. And I picked kind of an example. This is a bulkhead on the Cuyahoga River in Ohio. One of the big things there is because they have no river edge, fish had a hard time surviving. They get eaten. And so we basically worked to create like these baskets of debris that we shoved in between the ribbed bulkheads, and it gave cover to small fish so they weren't eaten. It has, it's not a very green thing, and most people aren't going to even know it's there, but it's actually providing an essential function for that habitat. So there's a whole study of things like this that are using biomimicry to find, how can we help with more kind of engineered solutions our ecological friends. And then last up the scale is kind of the big B, biodiversity. So this is, if you're serious about biodiversity, you need to hire scientists to focus on different things. And this is a wide range of biologists and ecologists and soil scientists and microbiologists to look at all of the things that we care and we're interested in. And with that, I wanted to share one maybe quick example because the tools that you may use in biodiversity may not be tools that you need to pay for. So we did part of a team that worked on a regional conservation assessment for the Denver metro area. And as part of that, we added in kind of this urban habitat connectivity study. And what we found, we were looking at like grassland connectivity around Denver. We're looking at riparian connectivity. And this is all the regional government spending resources to provide this information to the community. And so this is, and many of our regional governments have things like this, and so it's an important tool for corporations or other constituents. One way this was used right after this study is that if you didn't know, I didn't know this, Colorado has almost 1,000 native bee species in Colorado, second to only California, which is really cool. And so that was something that we're really interested in learning how Denver was doing with creating habitat. Bee habitat is, the connectivity of bee habitat is really important to them, and it really varies on the species. So some species have a very long range, some species have a shorter range. So this is 800-meter distance for the bumblebee, 250 for this other bee. And so they were looking at, depending on the species, how does Denver Metro rank in sort of creating habitat? Created some heat maps on the left. But what was really cool is the school district. If you can kind of see on the right here, there's a bunch of red dots. I don't know if this is working. Anyway, there are red dots on the right side, and those are specific school district properties, the schools, where the schools are at, or the properties that they manage. And so they were looking at, okay, how can we look at this large portfolio of land, and are there opportunities to enhance specifically pollination habitat on this? And so the school district didn't have to invest in all of this assessment. They just had to kind of use the assessment. So I would offer that to the corporate community, that it's likely the jurisdictions that you operate have a bunch of GIS data that you can use and mine, and it's there for you to use with projects like this, where you can really do targeted science to pull meaningful things out, enhance a biodiversity metric. And so wanted to make sure that we talked about that tool. They create, from that, they create very usable tools. So they did 30 assessments. They created maintenance manuals, like real documents for users to use. And all of this kind of came out of that study. So we know it's going to help the bee, but it's also going to help all of these other things. And all this came by using taxpayer investment that your community had in all of this GIS work. And I think this is my last slide. Biodiversity is not a static engagement. It adapts over time, and so every corporation should have an adaptive management plan, not only for your buildings, as we've talked about the last day and a half, but also for the natural infrastructure that's around them. So something to think about. Thanks. Have a good time.